Welcome to the Let's Talk Data podcast series presented by SAP.
Hello, everyone, and welcome to our Let's Talk Data podcast series 3. My name is Ginger, and I was your host for the first two series we did for Let's Talk Data, and I'm really excited to be back for our third series. This series is all about artificial intelligence and machine learning, and it's really focused on some new solutions we're providing from SAP. One of those is SAP Data Intelligence. And in this particular episode, we're really going to be focused on how did we get there? Why are we doing this? Why now? What is it about machine learning, artificial intelligence, data management, data orchestration, all these things? Why is this kind of all coming to fruition now? And what's SAP's investment, and what are our leaders saying about this? So today, I'm really thankful to be joined by two of our senior leaders in their respective organizations. Both have very deep domain knowledge and lots of expertise, so I'm super happy to have them here. One of them is located in North America with us, and the other one is located in Germany. Of course, by the way I talk, you can tell I'm located in God's country of the great state of Texas, so I'm about halfway between both of these gentlemen. So first I want to introduce you to Sebastian. So Sebastian leads our machine learning development organization. He sits on our AI ethics board. I've been tweeting out, he has some great 1.5 minute quotes responding to things like, will AI make humans go away, and all these kind of interesting topics that he's involved in. So Sebastian, thank you so much for being here. Welcome. Tell us a little bit about who you are. We know I think you're in Germany. I don't know if you're Berlin or Waldorf, where you are today and about what you're doing at SAP, Sebastian.
Yeah, thanks, Ginger. My name is Sebastian Wieczorek. I'm actually in Berlin, that's true. And I'm business lead of SAP Data Intelligence. That means that I am leading one of the development teams that are contributing to machine learning at SAP. Also, as you said, part of the AI ethics board that SAP has set up. In there, what we're doing is we're looking into how SAP is formulating its guidelines towards what is ethically compliant usage of AI. Do our products comply to AI, and also to safeguard that the products that are built and the projects that are started within SAP are complying to that. I'm also helping government organizations to formulate an opinion on AI. So, for example, I'm member of the ENCAT Commission or study group, it's called, I think in English, for AI of the German Parliament, meeting with the politicians there once or twice a month to discuss what to do in Germany towards making the best use of AI in society, in education, in economics, and of course also talk about ethics and their implications.
And I saw a board you were on, a panel. That's really good. It was a really interesting conversation. So you definitely want to check out Sebastian and follow him and see some of the things that he's involved in. So thank you for being here today. We're happy to have you here.
Happy to be here.
And I'm also joined by Mike, who's been around SAP for just about as long as Hasso's been around, or maybe not that long, but a really long time. He's got deep domain in many areas across SAP. This is early morning for you, so thank you for joining us. Tell us a little bit more about your role and what you're doing at SAP these days.
Yeah, thanks, Ginger. Yes, I'm Mikey Crude. I lead the product management team for our data integration, data management, what was traditionally called EIM products at SAP. And now, obviously, we'll talk about how that now also dovetails into our new SAP Data Intelligence product. And, of course, our predecessor product, which was SAP Data Hub. I'm based in Palo Alto. So the other side of the planet, Sebastian. I'm glad to talk to you about this.
So with both of these powerhouses here, I really want us to take this podcast and talk about kind of how we got here. So SAP Data Intelligence, it was announced at Sapphire 2019. It's generally available. It's being launched officially with TechEd and Strata this year. And we know it combines, Mike, you mentioned Data Hub, and Sebastian, you come from the artificial intelligence, Leonardo machine learning framework. So, Mike, I want to start with you. How did we get here? Why are we combining this? Just give us a little bit about the history. Why is this important, and why now?
Yes, I think it's good to take a little step back, maybe with some of the core foundation blocks of SAP Data Intelligence. So what we did about 3 years ago was we brought together all of our data integration, data quality, and what we call data governance products together under one roof. And we created a new team, and that actually was the genesis of the SAP Data Hub project and the delivery of that, which we delivered about 2.5 years ago. So that includes all of our data integration products, which is our ETL, replication, and messaging products together. We brought together all our data quality, and on top of that, you see data catalogs, the metadata management, and the governance products. Why we did that is we realized all those point solutions when it comes to looking at data management from the data landscape perspective. We're not solving the whole problem. The analogy I like to give is it's like public transportation. You have trains, which may be the ETL process. You have buses, you have taxis, you have Ubers. Now you have electric scooters. And we need to be able to have a very flexible way of managing data across the whole landscape. And obviously, from an SAP perspective, we came from a very much a process integration, so process data integration, where you have things like EDI and things like that, which came into things like cloud platform integration, process integration products, all the way through to analytics products, where we integrated from your ERP systems to your data warehouses. And we really looked at that underneath every business process, there's a data process flow. So we looked at how do we combine the very distinct technologies together to say, why can't we discover data from any source? How do we look at the sharing? How do we look at building these workflows, what we call pipelines, and connecting all the systems together, whether they be analytics, whether they be transactional, whether they be data services, whether it's a new expanded data networks where you start seeing data brokers and data as a service, and bring those together as one product. Now, why you would say, okay, why are we talking about some machine learning as well, is because obviously underneath that, we have the need to be able to do the full life cycle, not just for analytics, not just for data transactions, but also how do we make decisions on data. And if you think about decisions in the past, historically, they were either very much a transaction or a dashboard or a BI report that you made decisions from. Now we're automating that process. So I'd say with machine learning, we're starting to see that they're just another algorithm. They're just another decision-making tool. But really, those algorithms, how we train them, how we do the management of those from the full life cycle, is really how we see the machine learning evolving. So it's not just a case of where it sits in the corner and you have a great POC. It's how do you get the right data, how do you get the right metadata, how do you enable the data scientists, but then how do you build those models and deploy them, but have all the lifecycle management around them. How do you know the decision of an algorithm that was trained and released last August versus last October versus today? So really what we're seeing is that machine learning is now, we're going to say, the next thing that we have to tackle from the data flow and the management of an operational production data landscape. We definitely see a lot of machine learning projects do well in POCs, but the operationalizing and that full life cycle is the next challenge that we see, and they shouldn't be any different to how we look at process data or how we look at analytics data.
So before we move on to Sebastian, I just want to ask you one quick follow-up question. You mentioned that, we brought together our data integration ETL tools to become the Data Hub. And, which tool you mean depends on your use case. Like you use the travel analogy, trains, Ubers, scooters, all that type of stuff. So will these tools, just for the people listening, will they continue to be their own, or will all of this go to data intelligence? Could you just give us a little bit of, is there still a use case for them, correct?
Yeah, it's a great question. I mean, I think the public transportation analogy is very good there, Ginger, in that we can say, even though when we get, Elon Musk comes out with Hyperloop, we're still going to have trains and buses that they're going to connect to. So there's still going to be need for those ways of moving data. And if you think of the people movement as an example there's still going to be those ones that we take advantage of the core ETL. So there's still going to be need for bulk data transfer, cleansing and loading. That's definitely not going away. I mean, with the advent of big data, that's definitely more and more the case, but we're going to see the connections also to streaming and replication, but they shouldn't be independent of each other. You should be able to deploy a solution. Maybe one team does ETL, another team does messaging, like using Kafka. And then how do we connect those together? So we need to be able to have a technology that can introspect those individual deployments, and those tools, those products will still exist. whether they come from SAP or they come from open source or third parties, there will still be the need for those, but to be able to unify them and be able to understand what data is from where, or what metadata, and be able to unify them is really what we're doing with Data Hub. So it's not about simply ripping and replacing all the trains and trying to replace them with scooters. We're really seeing this as a place for how do we connect all of those and reuse them. So the existing workflows that our customers have, the needs to be able to deploy those products and then be able to connect them. So we, for example, have spent a lot of time showing how we can use SAP Data Services, SAP SDI inside of HANA, how to connect to existing Kafka flows, Google Pub Sub. How do you connect those into the same data flows, even if they're building in different technologies?
Okay, good. That clarifies that. That's good to know. So, Sebastian, earlier Mike was just talking about how we want to manage machine learning as part of our lifecycle management. And we know we had the Leonardo machine learning framework. It's being combined with Data Hub to create data intelligence. Would you maybe give our listeners a little bit of background on the Leonardo machine learning framework and kind of why is it being included and why is this a good idea from a machine learning artificial intelligence perspective?
Yeah, sure. But before I do that, I really liked your analogy here, Mike. What I would like to add here is when you think about the public transport situation, I think what we add with AI is, for example, the autonomous driving towards public transport, right? So it's not that public transport is not going to exist forever. It's not that that it's irrelevant to solve all these problems. But if you combine it with AI, if you combine it with machine learning, you start to get more and more automation. And when you think about data flows and when you think about what to do with the data, how to manage the data right now, what people are doing is they're defining rules of how to aggregate the data, how to clean the data, how to make use of the data. And here in these parts, there is the potential to improve efficiency and to improve the quality of what we're doing with the data using machine learning. So that's the one part of it. On the other side, when we're looking at it from an AI perspective, we see a lot of interesting application areas of AI in all kinds of areas, like when you want to build intelligent products that, for example, understand what are the product parts that you need to replace in the machinery when you put your iPhone or your smartphone to it and take a photo. For example, this is a case where a lot of companies want to understand what are the spare parts that they need to order or what kind of machine is in front of them. For that, you need to train an algorithm, and these are the cases that we focused on with Leonardo machine learning. We focused on customer-specific problems in their products, as well as customer-specific interactions with their customers, as well as solving customer-specific automation issues or challenges. With the help of machine learning. Now, what we see on the machine learning side is that a lot of these cases can only be solved by pulling data from various sources, by orchestrating them, by cleaning them, by utilizing them for the training, by then pushing data streams through the models that we trained in order to come up with these cool features that we want to put into the product. So not only from let's say in data orchestration and Data Hub side does it make sense to include machine learning into it. Obviously, also from a machine learning side, it makes great sense to combine forces and to integrate all these data handling capabilities that I'm now selling short here as well, obviously, to enrich the capabilities of a machine learning platform. And I think we had both teams talking about it from a technical perspective, that we would want to use each other's features internally, and then figured out actually the power is to combine both parts and to make this a holistic solution that includes the data handling aspects and the intelligence aspects, and hence starting to work on a joint product called Data Intelligence.
And Sebastian, I was just going to add to that. I mean, I think you touched on a good point about why they overlap with each other. I mean, if we look at the data scientists and their workflow that they have, I mean, it's that, as you said, data sourcing. How can they get a nice a la carte menu of the data that already exists, that there are data engineers and people who provide services within the organization or outside the organization to connect to understand the data, but also understand the flows of data and how they can get that data to their the data science playground where they want to build and train models. How do they reuse the metadata that they have? Because I think also we realize that data scientists spend a lot of time playing in SQL to actually prepare the data, and if they can have more productivity with that acquiring of data before they actually have to and spend more time training the models, we definitely see that as a huge benefit. And then of course, what happens after the models are built? The models aren't static. The data is not static. I always joke that data is like children and wants to move and get dirty, and I think that also becomes a problem for machine learning. In the biased or in the unfortunate mistakes that may be made in making those decisions, because I think it's only as good as decisions that are made. But that operationalization of machine learning, and then also the full life cycle. I think definitely we see those combined. Is something that I think any data scientist would want to do, and I think also not spend their whole day in SQL, but spend more time in Python and R and other languages to actually define better algorithms, but also how to set up processes to do like self-tuning algorithms. I think that's the interesting part for us, right? Is how do we actually have those workflows that happen in a productive customer's environment also influencing the machine learning algorithms.
So I would like to add that, obviously there's also when we talk about the challenges from a data scientist perspective, there's also the challenge of actually getting access. So the integration capabilities that data intelligence via the Data Hub technology is offering, this I think is something that is also outstanding here. So especially if you're on the SAP landscape side, having the possibility to connect to various data sources, combine information from the various systems in a meaningful way, manage the connectivity, that is something that you don't find in data science tools, and that is making it hard for data scientists usually to acquire information from those various enterprise sources. And one other part, when you look at it from a data science perspective, is that when we talk about the life cycle, it's not just the way you want to operate the models. It's also from a regulatory perspective, what kind of traceability and transparency do you need to offer to your customers and to your end users? So we all know this algorithm class. What they're doing is they learn by example, and it's not in all cases that a human can explain what are the rules or what is the behavior that these systems have learned. Now, if you as an end user are trying to understand or are questioning why did an algorithm take a certain decision at a certain point in time, what you need to understand or what you need to know in order to get an answer to that is what was the version of the algorithm that was running, but also what was the training routine which trained the algorithm, what was the data set that it was trained on, and what version of the data set, and maybe even who had access and where did the data set was generated from and by what method was it generated. Only then you have the full traceability from data source to the decision that is made. And obviously for data science, as you're not prescribing the rules by which the algorithms are working, you need this full transparency and you need the traceability down to the actual data that was used in order to be able to explain what it was. So from a legal perspective, that is very important. And obviously also the data access, data anonymization and other pieces tie into that then. And the data lineage and whatever else is there. And I think, Mike, you're much better positioned to sell all these cool enterprise-ready features here.
Yeah, and I think I think it's even a big enough challenge just for a data engineer or people, what we call data ops people, who are doing what was traditionally called the interfacing of data. Now with the new, what I would say, the extended data landscape, it's not everything within inside some company's firewall or inside the DMZ. We have the enterprise systems, we have the data warehouses, but they now may not actually be even in their own data center. I mean, we now see the advent of using multiple cloud solutions. I think we saw saw in a survey a couple of years ago that people had 5 to 7 different cloud solutions, and we're now seeing that even with the cloud applications. So whether it's SAP applications like Concur or SuccessFactors or Ariba, but now seeing like Salesforce or other non-SAP products like Workday, that people want to bring those in, but then also the advent of new cloud storages, whether it's object stores that are disrupting Hadoop, like Amazon and Google's, or you start seeing companies now like third-party EDWs in the cloud like Snowflake, and how do you bring those in? The acquiring and sourcing of data, I think, has just become even a bigger challenge for the data scientists. So for us, it was, if we still have the same access, the same catalog that the data engineers and data integration people are using, why can't the data scientists access that too? I think that getting data for the data scientists has now become a monumental challenge. And of course, getting it in a way that is consistent, right? Because I think if you think of just putting the other use case that we try and address with Data Hub as part of data intelligence is the new chief data officer role and the regulatory roles that we see about understanding you. You touched on anonymizing and masking of data. We now see a lot of this case is how do you make sure you're doing machine learning, but also adhering to GDPR. So how do you know what data is where? How do you know the data scientists have some data that might be need to be handled in a very specific way, particularly if it's in certain regions like the European region or the Russian region or things like this, where they have different data retention, different privacy, different usage rules. And definitely we're seeing this confluence of kind of like data governance, data integration, and the machine learning all come together. And I think that was, I think if you look at data intelligence, that's very much focused on what we're trying to do together, is to not to make one platform just for one user type, but actually how do we integrate those to make them usable by the different personas.
So would you both say that productivity, either data science productivity or developer productivity and governance are two of the key major benefits? That's just kind of what I'm hearing about the acquisition of data.
I think, Ginger, I would agree completely that productivity is one of the things that we see is how do we share and discover the data, but also the metadata, and then as it goes all the way through to the production process, how do you do impact analysis? So how do you have the lineage to do traceability, but then also how do you know if you're going to change something, what the impacts of that? How do we know if you change a table inside a data warehouse or change an API in a data service that you're offering, that would impact an algorithm that you're running and that was trained in machine learning 6 months ago. And I think that really that productivity is both from how do you develop, but then how do you operate. And we definitely see this, to use that term again, data ops becoming the new challenge for everybody, is because now it won't be just one machine learning algorithm that's very high value. When you look at IoT and digital twins, it's going to be thousands of algorithms running autonomously to the data flows. I mean, they're just going to be linked to data flows and they're going to run and they're going to self-train. And I think that movement away from human interaction and very point-to-point is something that we see from a productivity perspective. We need to deliver tools to our customers to help them do that. Sebastian, want to add about machine learning productivity? Because I think that's also obviously how do I do things much faster and move on to the next one, right?
Yeah, I mean, I completely agree, and I would put also a separate perspective in here. When you think about data science projects, I mean, they're data scientists. Obviously, they struggle with a lot of data access questions that you can take away from them by having this specialization and having operations people and data management and governance routines and specialists in place. But there's also a cost factor, I think, from a company perspective. So let's assume you would build a data science team that is end-to-end responsible for acquiring the data, managing the training, and then managing the operations of trained models. We all know that data scientists are a very rare species right now, and a very expensive one as well. So I think also, even from a business perspective, it makes a lot of sense to, instead of having data scientists operating the trained models 24/7, to have the tooling around it, so that operations people who are trained to do lifecycle management and do operations of these software assets are able to take this task over. And likewise, that you have data engineers that are trained to get the data out of their data sources to oversee the governance process. And I mean, what you obviously want to have as a data scientist, you want to have the freedom to use whatever tools you're used to in your day-to-day work. And what we do with data intelligence is basically to allow you to use whatever frameworks you find on the market. So we're relying on Kubernetes and Docker, which is allowing you a very, let's say, easy way to deploy and create your own assets. We're enabling all kinds of Python-based frameworks like Scikit up to TensorFlow, where we're basically integrating Jupyter Lab environments so that people can have an interactive way in their experimentation. It's not that, or what we're trying to do with data intelligence is to give people the utmost freedom, while at the same time leveraging all these underneath processes. Now, spoken from a data science perspective, leveraging the other processes that data intelligence is offering in terms of data management, data governance, and lifecycle management.
So you mentioned Docker Kubernetes. I think that's real important to discuss the platform this is on. So I guess this is not like an ABAP-based application, or what's different about this as far as Docker and Kubernetes and openness? If you guys could address that.
Yeah, maybe I'll jump in here.
Okay.
So SAP Data Hub was the first product, on-premise product, I'd say, from SAP that was built on Kubernetes and Docker containers. And the reason we did this was really the adoption of utility-type compute. So instead of in the past having dedicated servers sitting idle waiting for work, and then having to size for each project, what we're looking at is how do we switch and really help drive the on-premise use of containers. And this is, if you think why we do this, is really that if you think about data processes that you're building or data flows that you dynamically want to be able to say, I want to run this process, this workflow, or these certain operations, whether machine learning, whether they're bring your own code, running JavaScript or whatever you want to bring into those data flows. How do you actually provision those on demand, saying, I want this memory, I want this CPU, I want to use this Docker template. And this gives you lots more flexibility, as Sebastian alluded to, with you can have each container having its own version of Python, its own different libraries that you want to use. Particularly for machine learning, this becomes very important, as opposed to every single one being harmonized on a server. And then when it finishes, it gives the compute and storage and CPU and memory back to the infrastructure. So this really is about how do you do scaling, how do you share between these very different use cases that we see with data intelligence. So data science, the data engineer, data ops, all the processing of data that we would see as we integrate data in data flows. This is really why we built that on that. It's not an ABAP-based system, so it's a very lightweight, distributed, scalable compute that's based on Kubernetes. We also have within the product the ability to have open connectors. So we obviously have a long history of bringing connectors from our integration background, but also how we can have customers, partners bring their own APIs, bring their own connectors to their certain applications or data stores. And then also the openness, I would say, also is bring your own code. So this we see from people bringing their own, as I said, JavaScript, Golang, things like that, but also bringing their own Python, their own R, bringing their own libraries. If they want to use Pandas, if they want to use Anaconda, how do we bring those libraries in and say this becomes part of your flow? So how do we say you extract this data, or you have a correlation of extraction of ETL and streaming data that you want to harmonize, you want to do some data quality transformation, you want to do some anonymizing, and then run your algorithm and then take action based on it. So I think a lot of things also is with data intelligence, it's not just a new version of ETL where you load into a table, but really about how do you take action. So we can call services, whether it's an API into an ERP system or a third-party application in the cloud that we can actually take actions from. And for us, that underlying container technology enabled a couple of things. So one is that then we have out-of-the-box support for on-premise. with the operating systems like Red Hat and SUSE. Then also we support all the hyperscalers, the major hyperscalers, Amazon, Google's, Microsoft. And then also we have our own cloud solution with SAP Data Intelligence is actually a managed cloud solution from SAP built on the same technology. So if a customer wants to use Data Hub on-premise, they can choose to use our managed service and then get all the additional machine learning services as a managed service from SAP.
What's extra cool from a machine learning perspective is that we offer support for GPUs as well. So if you think about scaling the machine learning jobs, that's one of the essential things that you can run those heavy loads, especially on the training on GPUs.
Oh, that's great.
And I think that Sebastian, I think the fact that we can share those GPUs with other processes, so even for the on-premise deployments, non-SAP use cases. So it's not just a dedicated infrastructure that is only to a machine learning process, right? So those GPUs, those memories, those CPUs become available as a general purpose resource, which I think is great. And also in our managed solution, we also can use it for other processes, not just machine learning, any algorithm that would be relevant to a GPU.
Exactly. I'm just mentioning it because I think, especially on the cloud side, especially when you think about machine learning, you have usually high load of utilization and of your infrastructure, and that means that for a certain period of time, while you're running your training job, you want to scale out as much as possible, and then when you're going into production with your model, you basically go back to smaller instances that you can run it on, maybe on single CPUs or a small cluster of CPUs. I think that obviously we also enable that in the on-premise case. That's true, but the full scale out you can obviously only achieve if you go into a cloud environment. So yes. if you run your training on-premise, then you're bound by the confines of your appliance or of your own infrastructure. If you go into the cloud, then basically you can scale out, to the borders of what infrastructure the infrastructure that we're supporting and the hyperscalers that we're running on are offering.
Yeah, very good point, Sebastian. I didn't touch on that burst computing needed, particularly specific for, as you said, GPUs and the training of machine learning algorithms.
So you guys have mentioned the use by data scientists, data ops. You talked about the chief data officers in other key roles. What are some problems that you're seeing our customers address with this that you're seeing so far? Sebastian, earlier you mentioned people that take a picture. I think I saw a use case of that on machine learning where we take a picture of a product and we automatically know like what it is in a field service situation, what the spare parts are, and then maybe even look up, what the inventory is, or the use case where there's like take a picture of a product that needs to be fixed. I bring it into a store. It tells me, what's everything I have available. I think that was one, Sebastian, you mentioned. If you could talk about another one from machine learning, and then I know, Mike, you have several from your side as well. Could y'all just give me a couple of things, real things that we know customers are using this for?
Yeah, sure, I can. I mean, from my perspective, is the what you can do with machine learning is obviously a wide field, and people are doing a lot of those things. We have people using text analysis capabilities, for example, to extract sentiment or to categorize the text that they have. For example, if you're searching for help documentation, you say, okay, I have this document, give me similar documents or documents that talk about the same topic. That's an interesting one. Or you have images, you want to have a similar image if you feel that the image that you want to replace in a presentation, if you're in marketing, is not compliant, you don't have the rights to use them, you can search for semantically similar images. Same holds for time series analysis, where you want to do forecasting, for example, of sales prices, or you want to do do analysis of when did something go wrong in a machine, like predictive maintenance scenarios. What we see is that we're offering building blocks, and we have been doing that for quite some time, that can be reused by people. But the power of data intelligence, in my opinion, from a machine learning and data science perspective, is that we're actually allowing people to look at those assets that we're providing and change the inherent pipelines, the models, the training routines, if they need to adjust it to their problems and to their specific situations. And I think what we see right now is that many people are struggling with using the pre-built functionality that you can find. What most of our customers want is to tailor really to their data, to their situation, get the best out of the algorithms. And for that, you need a platform that allows you to really go into the details of the pipelines, to stitch together models, to change data pre-processing in a certain way. And that's what we're offering.
Okay.
Yeah, I'll definitely add to that, Ginger, a few use cases. So obviously with very broad buckets, we see a lot of IoT use cases. So a lot of that unstructured or semi-structured data coming in that we need to be able to analyze. And I would say it's not always the case that we bring the data into an ERP system before we make decisions now. We're now making decisions on data in flight. So where we're coalescing data, we're transforming it, we're enriching it, and then doing lookups and making decisions. So this is with examples of where you see things like images coming off production lines. So this could be real-time video images of a production process to make decisions based on quality. It could be, in addition, as I mentioned, the digital twin. So if I have predictive maintenance on production lines, that I make decisions based on each individual piece of equipment because each one is unique. It's not like it was when it came from the factory. Everyone has a different maintenance cycle, different usage, different maintenance done to it. And I think that's where we're starting to see is how do I actually have, if I have 1,000 similar pieces of equipment on production lines, how do I have 1,000 digital twins for those to be able to test this, my decisions, what I would like to make, and then which is the best one to actually make. So we're seeing that a lot in the IoT space, particularly as that tends to be very much disparate from what is the enterprise applications, particularly out of customers. You tend to find the IoT teams are different to the big data teams that are different to the data warehouse team, the enterprise data warehouse team that's different to the enterprise ERP systems, and how do we help bridge those? I would say also what we call big data warehousing or enterprise data warehousing. Then you look at this where you see object stores where people are storing all the raw data because they know it's valuable using object stores, and now they're using data lakes, but they're also using the enterprise data warehouses like HANA to be able to put the data for high speed processing, but also to be able to do that very deep analytics on it. And this is where we start seeing, and you might say, well, that sounds like standard ETL, but we're starting to see whereas data itself is coming in, it has to be harmonized. There's different levels of value, refinement of the data. We're also seeing machine learning actually on the data quality parts because people are actually using machine learning on the data itself to determine what the data should be, what it's corrected. Is there anomalies here on data actually coming in? Not just that it sends somebody to, an email to somebody's inbox to correct a piece of data. So we're actually seeing now machine learning itself being turned back on its data itself. I would say other use cases that we're seeing is around things like new ones. I would say is around like the experience. So Qualtrics type data. So how do we get surveys and bring that back? And for example, like surveys and people giving feedback on their usage of a service or usage of a product, and bring that together. And how do you actually look at how that's impacting maybe the sales or the marketing process? And I think this is a new type of data that we're seeing coming in, and customers are trying to understand how that comes in and how does actually affect what you're doing. We're also seeing a lot of third-party data influencing the data landscape. So whether that be weather data, whether that be shipping data from third parties, or things like asset information networks where you have multiple different partners all working together, whether it's the manufacturer, the maintainer, the customer, all working together on the same data. And these new types of what I would call data models is where we're seeing now a lot where data intelligence has to come in because people want to make decisions on the data. They want data flows, but they don't want to build things independently of each other.
Wow, those are great. That's a lot of good use cases.
I was just going to say we have a lot of use cases if you want to go to our webpage.
Yeah, in fact, on that note, we're actually creating a discovery use cases. It's not really an ebook. We'll call it, data intelligence use case discovery. We'll be able to go online at sap.com, look by industry, look at your use cases, and you'll see a lot of these examples. So just kind of in closing, just what's one thing that you would want to leave the audience with? You can definitely go to sap.com/data intelligence to learn more. But if they were going to take one thing away, especially a data scientist or an ETL developer who's listening to this or trying to figure out where they fit with this, what's the one thing that you would have them take away? Mike, we'll start with you, and then Sebastian will end with you.
Yeah, I mean, I think it's not a case, as I said, about replacing the trains and the buses. It's about how do we enhance the data landscape. So how do we actually have a set of tooling? And I think we have to take a step backwards and look at all the challenges that we have. We've been very good at solving individual point-to-point problems in the past, but I think what we're doing with SAP Data Intelligence is how to look at how a data engineer, an ETL developer, or someone who's doing data quality or governance, how they're going to look at not just process and analytics data, but how they're going to look at machine learning data and how they're going to take that holistic view and of course we know that landscape is going to be very agile. So I'd say really that's one thing I'd say we have to take a step back and look at the problem we're solving, because otherwise it ends up as a game we have in the US like whack-a-mole, right? So we basically are not taking and looking at how we architect this, and then how do we turn the data landscape into more of a services-based architecture. So how do we have that a la carte menu of data services like cleansing algorithms, lookups, the master data lookup systems, and cleansing algorithms that we want to be able to make sure that other people are using. So I think it's about how do we make it a service. And I think that's really what the underpinnings, I would say, from SAP Data Intelligence. What we're trying to do is, whether it's machine learning, whether it's somebody who's building analytics, whether it's someone building a new process to load data into an ERP system, how do we have that same infrastructure be used by all of them and really be productive?
Great. Okay, Sebastian?
Yeah, I cannot add much to that. From my perspective, I think data intelligence should be perceived, or I hope is perceived as a platform that is basically enabling all kinds of projects for a customer dealing with data. So it's not just one thing or solving one single problem. It's, in my opinion, a framework for driving innovation based on, or data-based innovation, I would call it. And it doesn't matter if you're trying to solve a challenge that includes machine learning or artificial intelligence or not. I think it's not this one case. It's from a company's perspective, it should be the idea that you get one platform to manage all your projects that are touching data, managing all your data sources, managing all your AI projects that are running, and governing all of that in one single place and with one governance model. That is, I believe, the most important part. And it's not so much about what is the data orchestration part or data management part of this, what is the ML part of it. I think these two things belong together, and the data handling and the AI part together form something that is way more valuable and more interesting than the single pieces on their own.
That's great. So the whole 1 + 1 = 3, right? Isn't that what we talked about as we were preparing, Sebastian? You get more.
Yeah, I think ML without data, it's not really even conceivable, right?
Yeah. Well, thank you both very much for joining. Sebastian, thank you so much. Mike, thank you so much. And we'll talk to you soon. Thanks for joining.
Yeah, thank you, Ginger.
Thank you.